here we go with the next installment of the podcast. And I think it would be helpful before we really dive into the conversation for you guys to explain a bit about what you do. I mean, we talk all the time about the differences between the European versus American facade markets and codes and governance that's driving a lot of decisions that are made. But especially with you guys coming with an approach and strategy that's been executed elsewhere, what brought you here to New York, and what it is that you're trying to push?
Good question. So we are thinking a lot about this. So yeah, we have a different approach, and I think the main important point, thinking about facade investments, and they are huge for building owners, is that we are simulating. We have a very, very close understanding of the building after our simulation, and we can prove to the building owner that investment into the building envelope really pays out. Yeah, so we calculate the KW hours room wise that a building owner would save if he would invest into the facade. And this is, I think, starting with a facade, doing really, really close evaluation of the building performance, and then designing the HVAC inside. This is, I think, for everything I've seen here, the biggest difference. So the market here is more focused to a very simple energy modeling, like it's called here. And so after the energy modeling, nothing is left. We are starting with the energy modeling, doing it room-wise, designing the HVAC inside, and prove to the customer that if he invests on one side, the building envelope, that he saves on the other side. Yeah, project.
So yeah, it's the Eliot. What have you seen? I had this conversation recently with Spencer and Helen about the lack of collaboration between the facade consultants and the mechanical engineers. Are you seeing that becoming more commonplace or a bigger topic of discussion?
Yeah, so I see a lot of product-driven renovations where people are out there pushing a specific product, say a heat pump, right? Whatever form of heat pump it is, and showing people theoretical gains that they can make in their building, in efficiency, and maybe uh, claiming that they can get to local law 97 or other carbon program reductions by just buying this widget. And that doesn't work. What Rule does differently that I like is they're looking at it holistically, right? And they're looking at not just the facade, not just the mechanical equipment, but they look at what's your actual energy use now. Let's plug in the numbers. Let's build it from a local weather data model, that local model that uses local weather data rather, and then build up from there. Because honestly, whether it's windows, hot water heaters, pumps, air conditioning, there's no one part of the problem that's the solution. It's everything, and understanding that how each part of it is going to affect the overall performance of the building is what's important.
So how do you have you done studies in terms of anticipating energy usage and output for a building, modeled versus as-built condition or actual values, and seen a disparity there? And has it sort of reshaped your perspective in terms of maybe building in some factor of safety or unknown error in that calculation?
Yeah, for sure. This is a big problem. So if it comes to as-built of building structures, we are measuring U values by ourselves. For sure, not the highest accuracy. So we doesn't have the best equipment for this. But yeah, sometimes you have to do it. Otherwise, you have no information. Yeah, you have to guess. So we are doing a lot in as-built for retrofits, and we are using then for sure energy consumption, and we are doing meanwhile a very, very elaborated utility analysis. Yeah, and we use it to calibrate our model. Yeah, we just did it for several buildings. We just finished an office building, full electric building. We are going to retrofit. It's a disaster, destroying energy, electrical P-tax, and yeah, it's it's a big effort doing the baseline calculation, but once we have our calibrated model, we can very easily do simulate different retrofit scenarios, including different window types, including different glass qualities. And we are calculating the kW hour saved. We are calculating the reduced investment for the pipe network, for the heat pumps. Converting fossil fuels. This is electric building, but every time the same. Converting fossil fuel buildings into renewable energy fuel buildings. You cannot convert one to one. Yeah. So doing so, you are just lacking heat sources. Yeah. So you have to understand the building, and you have to evaluate the triggers that you have to reduce energy consumption, and then a project will be feasible. Yeah, calculating required investment, calculated savings. So you have to see the whole building, the holistic project, and we are doing it a lot. Yeah, comparing baseline energy consumption and retrofit energy consumption is a very, very big part of our work. Yeah.
Eliot, how do you explain that to, I'm trying to wrap my head around it, but to people that aren't really deep in this industry, looking at an existing building with so many unknown variables, being able to make the claim that if you replace your roof or your lighting or your windows or you add insulation to this area, you'll reduce your, energy bill by this percentage. There's so many unknowns and unknown factors that it would be a falsified statement to be able to make a claim like that, I would think, unless I'm wrong.
So we have to explain it to people who are deep into the industry, not just people who aren't, unfortunately, because, Michael just mentioned calibrating the model, and that's the key. The model isn't something that you enter numbers into, set it up, present it to the owner, and you're done. You have a lot of information that's constantly evolving that you need to collect. Like they mentioned, U value. That's where we come in as a testing lab or as a measurement and verification entity. We measure the actual air leakage, either of the whole building, parts of the building components like fenestration, regular facade walls, and then U value, which we've been working very hard to get a really good, accurate U value measurement system where we can physically measure the U value of something, but that calibrates the model. And the calibration of the model is an ongoing thing. We just had 2 years of very unusual energy usage in most buildings. Well, if you just did your model based on the COVID years, your model would be upside down today. So it's a matter of constantly looking at it, looking at population density in these buildings. People are just going back to work in offices in a lot of cities now. So we have to look at the models again and recalibrate based on figures like that, because everybody has every physical body that walks into that building is a load on the systems and has to be entered in and recalibrated based on population density and other factors.
Absolutely agree.
And when what you were saying about, people, listen, it's the nature of the beast that people are going to try to sell their solutions for energy problems, right? And for efficiency problems. And this is not a knock at any of those solutions. Most of them are good, whether it's aerogel insulation or hot water heat pumps, whatever it is, they're all good. It's just over promising results to the client that I have the problem with, because if you don't have that very, very well calibrated model and explain to them that just doing the facade upgrade without doing control upgrades, you won't see that savings right away. But each one of these is a part of the end game that you have to have somebody like Rule involved as your program manager, because it's a program. It really is a 10-year program to get most of these larger buildings or more, because we have projects that we're involved with that aren't even starting for 8 to 10 years, even though they're doing a lot of the work now in baselining their building and doing retro commissioning. They aren't going to start the upgrades for 10 years. So it's a long process. And I just did a AI presentation last week, and the first slide was about teams, that you need a team to help you with this endeavor. And the main part of the team is usually the mechanical engineering firm that does this model and is uh, the uh, the master of the model, right? That keeps tweaking it and keeps adjusting it and keeps running different scenarios for the owner to say, if we do this, this is where we'll be at. If we do that, that's where we'll be at.
How much do you think building automation comes into this in terms of lighting systems and even like automated operable windows to know when to and not to leave the window open, when the mechanical system shut off to allow fresh air, or automatic shading system, or all these various components that can optimize, energy usage and allow the building to, play in more of a passive um, function. Is that something you see a lot of overseas and you think will be adopted here?
Um, I give an example for this. Room controls. Yeah, very good example. We are right now in World Trade, so we have, I think, on each floor we have 6 zones, not more. So normally we have one room, one zone, right? So reducing the room temperature by 1K based on degree centigrade, 1K will save 6% of energy. So a bundle of measures: room control, hydraulic balancing, which means constantly reducing flow rates, constantly reducing savings for power, constantly reducing thermal energy loss. We can save in existing buildings up to 35% of energy without doing anything other than controls. And we are state of the art right now, IoT-based controls for retrofits. We are doing wireless communication, and we allow user interfaces. Yeah, if I want to change any room temperature, if there is a possibility, I have to go to reception. They will adjust somewhere. So if the tenant, and this is even more valid for residential, if the tenant have access, if the tenant can save, if the tenant can adjust weekly programming, constantly reducing demand-based heating, demand-based cooling, then together with the right mindset, for sure, yeah, people need to be aware that they can influence the energy cost. Yeah, control is a big issue and a very, very good approach for saving energy. Yeah.
Where do you think this matters more, in the office or the multifamily residential application?
With in office, yeah, I would say in office, since we see that after COVID, home office use, so offices are timely empty. So see, Mondays, Fridays, yeah. So, but some people are there, some people are absent. So sometimes some usage can be scheduled, some not. And if people have a mobile access to their room, to their zone, and they can say, okay, normally I'm in home office on Monday, but I have a meeting now. Yeah, then he can adjust his temperature. So office, I think we have a more irregular, not permanent use. In residential buildings, normally people are leaving in the morning, returning in the evening, so it's much easier to adjust. But it's also a good saving in residential.
It's changing though now that we're seeing so many people working from home and home during the day, and I wonder how much that's going to play into it. I mean, Eliot, I wonder in your thought, what at one point used to attract a tenant versus what attracts them today, and when people are looking at where they're going to move, how demanding or how much their preference is going to lean towards occupant comfort and being able to have control over their indoor environment, especially when it comes to temperature control or air quality or anything like that.
So I just want to say that you guys just reminded me that Durst was supposed to put us on the email for the monthly weather data from the BMS at the building you're sitting in, and I just sent an email to them. But because we're trying to get more localized weather data from the buildings with the BMSs, because it's so simple. All they have to do, the system's already spit out a weather report every month, and we just want to start putting our database together so we have the island of Manhattan split into 4 or 6 or 8 weather zones, because the weather on the island is totally different between Midtown and like where you guys are sitting right now. Getting back to what you were asking, Adrian, so it's going to be very hard in residential, especially residential that was built in the last 25, 30 years, because P-tax, we talk about electrification. So I haven't worked on a gas building in 15 years because about 20 years ago, owners figured out that it's much cheaper for them to put an electric PTAC in every room than have a central plant system. So we basically electrified 15, 20 years ago, and uh, it it's a challenge because PTACs are notoriously leaky for air. The ones that were made before, maybe 4 or 5 years ago, weren't great at efficiency wise converting electric into BTUs either, so they weren't great. They're still not great, no matter what the tag on it says. They're really not great. But that's going to be the real challenge because those things are on off, no variable anything. They're, as I said, they leak so much air that even if you are keeping the room at a reasonable temperature, it's running so much to recover from that air leakage that it really just, you never, it's like being in a motel with one of those through wall air conditioners that keeps you up all night because it's noisy, but you never feel comfortable. You're either too hot or too cold. So I think residential is going to be hard. And I do think that because people aren't in their apartments during the day, they can set these things down lower. And we probably can, just by training people or encouraging people to, set it so that it's low when you're out. And when you come home, turn it back on, you'll be okay. But in office buildings where, a floor like you guys are on might have 1,000 people on that floor during the day. That's where we see that pattern, that population shift going into the office buildings during the day, which is going to be more and more every quarter for the next 8 or 12 quarters because people are getting back into the office. So I agree. I think it's office buildings first and residential buildings second, just because the load patterns seem to be it seemed to indicate that office buildings would be the one that I would attack first.
What was the Elliot? What did you say when we spoke to Ian that when you were a kid they used to shame you into turning your lights off and
Oh yeah, no, every classroom had a little sticker on the light switch that said turn off, and there was water conservation stickers all over. When you were in school, if you went to a public school in New York City, we used to get the lecture all the time, and there were stickers all over the place. But my parents, like I think a lot of other parents my generation, would always say, shut the water, shut the light when you leave the room, because you know our grandparents grew up during the Depression and they knew what it was like to not have money to pay that electric bill.
That's almost like Germany.
Exactly.
It's you grow up with high energy tariffs and you get trained and you're living this culture and mindset where you just have to carry around energy. And even now more than ever, if we get back to the transatlantic bond, what's happening in the US, what's happening in Europe, we've never been in this situation based on the conflicts that are happening in Europe. I don't even know what our gas supply now looks like, but a lot of people are becoming or getting under pressure. So it's always been our approach facing high energy tariffs to look for energy efficiency first. And then when Michael talks about that one-to-one replacement, you can only replace fossil fuels with renewable if you do your homework first and become energy efficient. Understand the building, understand the loads, what can we do where, what does the building actually need, and then you replace it with renewable energy. So that's been our approach.
Are you guys finding people here have that mentality that we have to do the efficiency first before we electrify, or people just
Many.
rushing to electrify?
Yeah, many. So this is surely not the standard approach here, but yeah, there are so many people. We are working very close together with NYSERDA, and yeah, we have exactly the same mindset. Yeah, many people with exactly our mindset. So working hard and yeah, working hard to find out the right approach to convince other people, yeah, to get it really to get it happen. Yeah, but yeah, there are many people exactly having the same mindset.
Plus, I think that the market has been facing these since Local Law 97 was published. I guess everybody is kind of wrapping their heads around how to approach this, how to do this. And they've been doing it since 2019, I guess. But we only came here 2 years ago. And there's been a lot of things happening. And we feel after we entered the market that building owners were like, well, let's try a new approach because maybe things in the past was just a learning. Now we try the European way, for example, and give it another try. And the building owners that we've been working with are very well accepting that different perspective on things. And
Well,
yeah,
even in 2 years from now, we're still going to be on that learning curve.
yeah.
And the next sort of um, evolution of local law 97 kicking in 2030, we still have a lot of time, and the building program and turnover, it takes a long time, as Eliot said. But what have you picked up on, I'm curious, in the New York market over the last 2 years in terms of how building owners or developers view the design process and how sort of green or efficient they want to be going into the building versus how the building is actually operated? Do you think there's a major disconnect there? And do you think enough weight is placed on both ends of it?
So from my perspective, what we've been seeing is, so Local Law 97 really opens the door for a conversation. It's not necessarily the main driver of the project because these fines, depending on the performance of the building, aren't always that extreme. They will become extreme, but they're not there where an owner says, well, let's do everything at once. And that's not what we want. We don't want to do a project all in, let's do the entire repositioning of the building. We just want to get there step by step as the law evolves and as compliance goals hit over the next 5, 10, 15, 20 years. But that opens the door for us to talk about what we've been doing for the last 25 years all across the world, is decarbonization. And it starts to shift from, well, this is Local Law 97, this is the door opener, but we're realizing that this can actually become a business case. If we save energy, if we upgrade mechanical systems, there's been an office tower we've been working on. If we can replace that perimeter PTAC and start heating and cooling through innovative technology, maybe through the ceiling, that's rentable floor space. That's like, if we calculate that throughout the entire building, that might pay for the entire project itself. So it's coming from this fine to a business case, is that what I personally found really interesting, because then it becomes even independent from any ESG, which we obviously want to impact on, but it's actually driving the owner to, I have to say how it is, but it's money making.
Yeah, absolutely. And it's money making at today's energy rates. Imagine in 10 years, plus comfort. Older mechanical systems are loud and they don't make the space as comfortable as modern ones. And when you're in a conference room and you can't hear the people speaking because the air just kicked on, boy, that's not a great space to rent to somebody, or you're not going to have a satisfied tenant.
Yeah.
Exactly.
And there's laws and regulations in Germany. I mean, I remember when we first came out here, and I didn't even know what a PTAC was up to then, and I heard that
You
noise,
still
and
did it.
it's
I
like
wish you didn't.
in Germany, there's regulations on how loud the equipment can be, and Michael knows it better than I because he designed over 20 hotels.
So we are talking about 28 dBA, 28. So your PTAC hits overnight 55, right? I measure it from time to time. Yeah.
The Americans snore loud, so they want to try to block out the noise.
I guess.
But no, that's interesting. Do you think? I mean, I wonder if have you guys spent any time in any other major markets in the U.S.? I wonder if it's going to require some type of accountability code is the wrong word, but some type of code that measures the as-built performance. And you have that being implemented, or at least sort of a test pilot in some other cities, but nothing as ambitious as Local Law 97. So do you think that's the ultimate driver that's going to get people to take renovating and upgrading existing buildings seriously?
This from one side, but this is not the only driver. The other driver is the tenant being at a certain time just not willing, paying high rents, high leases, and high energy costs. Yeah, depending on whose utility meter the heating and cooling is. Yeah, different systems. But it's pushed more and more to the tenant side, as I can see it. Yeah, this is the driver, and ESG. ESG for sure is a driver in the office, in the commercial building and industrial area for sure. Yeah.
Yeah.
So
Yeah, I think I steal a lot of what I say from Eliot, but a lot of these upgrades are not going to be driven by the energy utility bill savings. That's sort of a secondary benefit, but it's ultimately going to be either they want to compete against the building next door, or they can't attract tenants anymore. So the energy savings is going to be that nice additive selling point. But purely looking at the energy cost saving, you can't rationalize pouring this much money into the building.
So electrification means that you're replacing gas that is not too expensive here against quite expensive electrical power. And if you do not make it smart, if you do not focus COP, if you're going to PTHPs, yeah, and then your energy bill will be higher, even higher. If you are going for reasonable COPs, reasonable heat sources for heat pumps, then you're focusing COPs between 4 and 5, yeah, SCOPs even higher, then I think you also can influence your energy bill. But if you do it in a stupid way, and believe me, I've seen many stupid projects here in New York City, and then you won't save money. You will even increase your energy bill. But this, perhaps you will see it only later, since people do not calculate so much. Yeah, so people will see it some years later. Oh, wow, what happened? Yeah.
Plus, we can't count on subsidized low energy costs here in this country forever, especially not with the geopolitical situation right now. The largest producer of natural gas is at war right now. And, yes, we are secure and we don't have an immediate issue with our energy supply, but we have a long-term issue with energy supply. Forget about carbon reduction. Security is a big part of it too. We don't have unlimited energy now, and we're not going to get it from solar. We're 40 years behind, as is Germany, on building nuclear reactors. I don't even. You guys just made it legal again to build nuclear reactors, right? In Germany, they just passed it this year, correct? But
I know that.
Shut down.
I know we shut them down.
Last have been shut down. No nuclear power anymore in Germany.
So we can't get to what we need to do without nuclear. We just cannot build enough solar panels and windmills to get us there. So if we don't reduce, we don't have supply to electrify everything and reduce carbon. And we are relying on energy coming from a lot of places in the world where we are not very light. So we need to, you know what? I know I laugh about it too, but the truth is, Michael and I lived through the 1970s oil embargoes, and it wasn't fun. And that could happen tomorrow. And we don't have the security to say it won't shut down the rest of the economy. If you think COVID shut us down, imagine if OPEC decided to shut us down tomorrow or cut back on production because for whatever reason.
Yeah. So in Germany, we lived it through. We were almost shut down. So we had plans for industry, which industry, which is not absolutely necessary, system relevant, should have been shut down. So the gas supply had been really scheduled. So it didn't happen. We had not a very severe winter, but it could have.
That's why.
We faced it.
Because it could
we
have
really
if we
faced
had
it.
a bad winter.
Yeah. And now you have industries that are very upset. They said, okay, it could have happened. Yeah, and now they are working very hard to decarbonize. So most of our projects in Germany are industrial projects, decarbonizing industry now.
Yeah, and it's as much about security of this country as anything else. People don't look at it that way, but what we went through for the last 2 years in Europe was scary because for 2 winters, everyone was worried, what is going to happen this winter if it's a cold winter and this crazy man decides to cut us off? And that would have been terrible, like terrible, loss of life, terrible.
That's it. And nobody could imagine before. Everything was so safe. So heating homes was safe. So and then people thought, okay, how if I cannot afford anymore heating my home, how if I cannot get enough energy, reducing temperatures. So this was absolutely new in Germany.
And
you didn't know it.
And that brings us back to the conversation, Eliot, when you were a kid and you were told to shut off the lights, shut off the water. That's where Germany has always been. And now the conflict 2 years ago just opened a lot of eyes again. It's as if people say, Well, here's a plug. I just charge anything. I charge this. I don't even care where the electricity comes from. I just know it comes from there. But I don't really care how it's done, where it's basically produced, generated, and what it means for overall economy at that point. But yeah, very, very interesting how we are analyzing it, understanding it, and there are pathways forward for it. So it's not that we're with our backs against the wall. There is opportunity and solutions for this climate crisis, I would call it.
So it's very interesting. Kevin and Michael, what's the best way for people to reach out to you and get a better sense of the type of projects you guys are working on and capabilities?
So in New York, it's obviously the existing building stock. It's retrofits, it's high-rise residential, commercial, industrial. We do everything. We're more than happy to talk to anybody or everybody. It's always a pleasure talking to you, Adrian. A pleasure talking to you, Eliot. I truly believe that you understand everything about the facade, which we explained in the early stage of this call. Is we need to understand our buildings, we need to understand our facades, and if we know that, we will be able to design a very innovative, energy-saving mechanical system. But yeah, I mean, to everybody who's listening to this, feel free to reach out. We're always happy to explore synergies, opportunities, discuss what we've been doing overseas and here now, because this market is so massive, it's so big, and we all need to work together on this one goal together.
Completely agreed. All right,
Yeah.
everybody. Thanks for hopping on. It was a good conversation.
Absolutely.
guys.
Thank you.
Take care.
Thank you guys.